This evening, we will delve into a concept so commonplace that it's seldom questioned, yet so immense that it subtly disrupts our perception of magnitude. The light year, a term frequently encountered in documentaries, textbooks, and news, is often treated as a standard unit. However, a genuine comprehension of what it quantifies, it profoundly alters your perception of the cosmos. It transcends being a mere statistic, transforming into a portal revealing distances so immense they nearly defy imagination. Let us embark on this exploration together. If you're keen, please subscribe and join our quest as we reveal the world's insights and narratives. Etched in the cosmos, we commence by examining a reassuring concept: the perception of distance you instinctively grasp daily, often without conscious awareness. You traverse an environment structured by known lengths of space. You're acquainted with the sensation of a 1-kilometer walk, the duration of a drive across town, and the cognitive pattern of a journey to a nearby city. Your mind stores these spatial measures like ingrained blueprints. A kilometer aligns with the rhythm of your steps. A few hundred kilometers correspond to the hours of a day, and even the planet's entire perimeter. 40,000 kilometers around can still be mentally contained as something a vessel might circumnavigate, or an aircraft might trace across the heavens. A kilometer integrates seamlessly into that framework. It's a stroll lasting 10 minutes, a segment of pavement or rural path your recollection can revisit from numerous journeys. 5 kilometers is barely a chore. 20 kilometers turns into a half-day excursion. Even 100 feels concrete if you've ever embarked on an extended road trip. And observed settlements gradually pass by your window. These distances are integral to your daily patterns. You can visualize them, foresee them, and perceive their magnitude. Expand the scope further, spanning a region or traversing a nation, and while the figures increase, they still remain comprehensible to your mind. You can integrate them into hours, alongside mealtimes, and with shifts in landscape. A 5-hour drive transforms into slowly ascending peaks on the horizon, or a sea revealing itself following a final bend. You can recall its visual aspect and the sensation of remaining stationary while the scenery passes. Separation continues to be something your intellect can comprehend, something that is contained within the framework of recollection. Even the Earth itself, for all its immensity, can be formed into a cognitive construct. Upon hearing 40,000 kilometers along the equator, you envision navigators charting its perimeter with sailing vessels and commercial aircraft circling it. Within 48 hours, the planet transforms into an immense yet bounded sphere, a globe theoretically circumnavigable on foot, provided your lifespan was sufficient, and your endurance boundless. It's large, but it's not beyond understanding. It still resonates with human-sized proportions. However, the instant you venture past the planet's exterior, a delicate shift starts to occur. You gaze skyward, and the heavens that previously encompassed your reality abruptly disclose expanses that defy familiar patterns you've previously encountered. The luminous and well-known moon appears within arm's reach with a sufficiently extended ladder, yet its actual separation is 384,000 kilometers. It's like a foreign language number. You can utter it, but you can't truly grasp it. There's no method to transform that figure into something your physical senses or recollections can comprehend. The explanation is straightforward. Nothing in your existence has ever been so remote. Not even a tiny fraction of that span was encountered by your forebears when they observed, hunted, or collected. Cosmically speaking, the moon is nearby, but from a human perspective, it's incredibly distant. It drifts in an environment devoid of pathways, markers for scale, or landscapes, offering only quietude and void. Upon their journey to the moon, the Apollo astronauts departed from all familiar terrains the human intellect was designed to traverse. Their 3-day expedition through the emptiness demonstrated the sheer incomprehensibility of even the closest celestial object. Moreover, they were traveling at an immense velocity, significantly exceeding any speed encountered in everyday existence. At 11 kilometers per second, in a single pulse, they journeyed further than you would on a morning walk. Within 1 minute, they traversed a greater span than you might cover driving for an hour. Nevertheless, despite such incredible velocity, they spent days drifting towards the moon. This juxtaposition of vast speed and extensive duration unveils the genuine essence of cosmic separation. A sheer, featureless expanse devoid of the reference points that lend meaning to scale. Gaze even further, and humanity's perception of spatial extent utterly breaks down. The sun lies approximately 150 million kilometers distant, and at such a scale, kilometers transform into inadequate measurements. One can multiply the figure, record it, or contrast it with other values. However, it never forms a clear image in your imagination. Your innate understanding falters beneath the overwhelming quantity of zeros. You are aware of the sun's great remoteness. Yet you cannot truly conceive its immense distance. Your sensory faculties lack experience with such vast scales. Still, the solar rays that daily warm your countenance commence their voyage 8 minutes prior to reaching you. This solitary piece of information holds a subtly astounding reality. Even light, the swiftest entity known, does not arrive at our location instantaneously. It is compelled to traverse an abyss so immense that the cosmos's maximum speed requires minutes to cross it. When observing the dawn, you are witnessing an event from the immediate past, projected onto the current moment due to light's temporal lag. Contemporary spacecraft extend this understanding even more profoundly. The Parker Solar Probe, a device moving at almost 200 kilometers per second, requires several months to traverse the expanse separating Earth and the Sun. Months of uninterrupted movement, months spent hurtling through the inner solar system at such an extraordinary velocity that the full breadth of the contiguous United States would flash by below you in under a second. Nevertheless, even that velocity scarcely impacts the vastness of interplanetary separation. By this point, the kilometer has become nearly meaningless. It is excessively diminutive, overly localized, too entrenched in the realm of thoroughfares, waterways, and urban grids. Within the solar system, millions of kilometers now function as inches once did. Furthermore, as one ventures beyond, towards the stars, even millions diminish into insignificance. The figures expand until they resemble abstract concepts rather than actual measurements. And more akin to theoretical symbols, entities one can compute with but not mentally picture. There's a subtle sense of modesty in grasping this. Humankind excels remarkably at quantifying. Our capacity for counting and quantifying is limited. Our innate understanding developed in a far more confined setting. It wasn't built to comprehend the vastness of galaxies or the profound expanses of space. Upon encountering the boundaries of that innate sense, an extraordinary event occurs. You gain insight into a significantly vaster realm, extending well past your inherited confines. Astronomy operates within this transitional area where conventional instruments prove inadequate, necessitating the creation of novel ones as kilometers grow impractical. When figures like millions and billions cease to be meaningful, astronomers rely on the sole consistent measure offered by the cosmos: the velocity of light. Light travels at 300,000 kilometers each second. It remains constant universally, regardless of one's perspective. It's the singular measuring device that neither flexes, extends, nor shatters. Its nature is so foundational that both space and time conform to it. Given its unvarying velocity, light not only brightens the cosmos but also quantifies it. Each second of its journey transforms into a measurement of length. Each minute serves as a connection, every hour a vast chasm. Time itself transforms into a metric of space. Initially, this concept seems unfamiliar. However, upon deep contemplation, one recognizes it as the ideal answer. Light stands as the sole voyager that interacts with all elements. Within the universe, it departs from stars, traverses the emptiness, and arrives at our location, conveying data about locales we will never personally experience. If one quantifies space by the duration its illumination requires to reach us, you employ the cosmos's inherent timing, its natural cadence, its intrinsic standard. Here, the human-centric scale dissipates, and a universal scale assumes prominence. What commenced with walking steps evolves into something gauged in light seconds. What started as pathways is now quantified in years of traversing at the maximum possible velocity. What originated as a breakdown of intuitive understanding gradually morphs into a novel concept. A comprehension molded not by personal encounters, but by the profound, refined physics governing the cosmos. Once this paradigm shift is embraced, once you release the notion of walkable distances and accept the vast expanses light must traverse, the universe reveals itself. To grasp why light serves as the cosmos's standard, one must truly comprehend the peculiar nature of its actual conduct. Superficially, the velocity of light appears to be a straightforward concept, merely another numerical value in physics, yet this is not the case. It represents one of nature's most profound constants, intrinsically integrated into the very fabric of existence. Its velocity is so foundational that both time and spatial dimensions distort around it. Its velocity is so steadfast that no object possessing mass can ever attain it. This very consistency enables astronomers to employ it as a standard of measurement. Throughout the universe, consider the figure itself, 300,000 kilometers per second. While easily articulated, it is almost beyond human capacity to truly grasp. In each passing second, light traverses a span that would require weeks for a person to cover on foot. In the mere duration of a blink, it crosses the Earth's diameter multiple times. Envision a finger snap. Within that minuscule time frame, light has already journeyed a greater distance than certain spacecraft cover over an entire year. However, even that comparison fails to capture its true essence. Light doesn't merely travel quickly, it moves at the absolute maximum speed physically attainable by any entity. This isn't merely a constraint for engines or machinery, it's an inherent boundary woven into the very structure of the cosmos. Should one attempt to envision the universe devoid of this restriction, its entire framework disintegrates. It transforms into something unrecognizable. Without the speed of light serving as a demarcation, both space and time cease to function in a foreseeable manner, and the principles of cause and effect unravel. Physics loses its fundamental stability. The narrative of our discovery of this velocity commences many centuries prior to Einstein's popularization of it, specifically in the 17th century with a Danish astronomer named Ole Romer. He observed an odd phenomenon during his observations of Jupiter's satellites. Their eclipses occurred either sooner or later than anticipated, contingent upon Earth's position within its orbital path. Romer understood that the discrepancy in timing wasn't due to Jupiter's erratic behavior, but rather because light required a quantifiable duration to traverse. This was the first empirical evidence demonstrating that light travels at a definite velocity, not instantaneously or through supernatural means, but across the varying distance separating Earth and Jupiter. Instead, it behaves like a voyager traversing space. Over the subsequent centuries, researchers enhanced these measurements using instruments such as telescopes, spinning mirrors, lasers, and ultimately atomic clocks. Humankind determined the speed of light with remarkable accuracy, 299,792.4458 kilometers per second. However, when considering vast cosmic distances, 300,000 is sufficiently precise. Once you start conceptualizing light as a journeyer, time itself transforms into a standard of measurement, with a single second becoming a unit of spatial extent. 300,000 kilometers per second translates to 18 million kilometers per minute, then 25.9 billion kilometers per day, and a full year encompassing each of those seconds equates to 9.46 trillion kilometers. A year of light's journey represents a year of unyielding, continuous velocity, a year devoid of interruptions, deceleration, or exhaustion. This immense distance is so colossal that it serves as the sole suitable instrument for quantifying the expanses separating stars. Yet upon acknowledging the speed of light as the cosmos's standard of measurement, a further understanding comes to light. Everything observable in the celestial sphere is observed with a time lag. When you consider light's journey to your eyes, you no longer perceive the universe in its current state, but rather as it existed previously. Light requires time to reach us, and this duration creates a disparity between actuality and observation. When gazing at the sun, you are viewing it as it was 8 minutes ago. Were it to disappear at this very moment, a purely theoretical situation, Earth would remain unaware until its final rays reached us. The moon, by contrast, is merely 1.3 seconds distant. Nevertheless, even that minuscule delay illustrates the fundamental principle. Nothing you perceive in the celestial realm is genuinely happening in the present moment. You are perpetually observing the past, appearing as the current time. This is not an optical trick. It is an inherent truth embedded within the operational mechanics of the universe. Light conveys data, and this data propagates at that singular universal velocity. Consequently, the greater an object's distance, the more ancient its visual representation. A star situated 100 light-years distant could have undergone transformations ages ago, and a galaxy a billion light-years away offers not a view of its current configuration, but rather a depiction of its early stages. When one gazes sufficiently far into space, one is not merely perceiving spatial separation. You are witnessing history unfold. This inherent connection between spatial separation and temporal progression has unveiled one of contemporary physics' most significant revelations. The velocity of light transcends mere swiftness. It represents the cosmic velocity ceiling. No object possessing mass can attain it, for as one approaches that ultimate threshold, the fabric of reality exerts increasing resistance. Picture yourself aboard a train traveling at 50 kilometers per hour, then throwing a ball at 20. To someone observing from outside the train, the ball's speed appears to be 70. Velocities are cumulative. This principle is straightforward, yet it ceases to apply when one nears the speed of light. Consider a scenario where a spacecraft is journeying at half the velocity of light. Should it then activate a flashlight, common sense would dictate that the light beam ought to propagate at 1.5 times the speed of light when measured by an external observer. However, that outcome does not occur. Rather, both individuals within the vessel and those observing from without perceive the light as moving at precisely the identical velocity. At 300,000 kilometers per second, this unwavering speed necessitates that space and time inherently reconfigure themselves. For an observer in motion, time's passage decelerates. Spatial dimensions shorten, and timekeeping devices operate at varying paces contingent upon their movement. These phenomena are neither deceptive appearances nor mere theoretical constructs. They represent empirically verifiable physical consequences. Such effects are detected within laboratory settings, particle accelerators, and even the satellites enabling your phone's GPS functionality. During the rapid-fire collisions occurring within particle accelerators, subatomic particles exhibit significantly extended lifespans compared to their predicted duration. Their intrinsic temporal mechanisms decelerate as they draw near the velocity of light. This observation is not theoretical conjecture, but a directly quantifiable phenomenon. GPS. Satellites traverse Earth's orbit with sufficient velocity and at an adequate distance from our planet's gravitational pull, causing their internal timepieces to operate at a distinct pace compared to identical clocks situated on the Earth's surface. Engineers are compelled to factor in this relativistic alteration. Otherwise, your mobile phone's navigation system would deviate by several kilometers within a few hours. Universally, this cosmic principle is rigorously upheld. No entity can surpass the speed of light. This fundamental constraint influences every aspect of existence. It dictates how celestial bodies interact with us, our methods for charting galaxies, our approach to space exploration, and even the scope of future possibilities. For civilizations yet to emerge, one cannot merely construct a more powerful propulsion system and expect to exceed this limit. The universe offers no easy bypasses. Light serves as the supreme conduit of information, steadfastly maintaining its preeminence. Consequently, the light year becomes virtually indispensable. It is far more than a mere convenience. It stands as the sole unit of measure that harmonizes with the most fundamental principles of the cosmos. While a kilometer quantifies the terrestrial realm traversed by your forebears, a light year quantifies the vast expanse constructed by the universe itself. Furthermore, once the velocity of light is adopted as the foundational pillar of cosmic metrology, the separations to our closest celestial counterparts abruptly acquire profound significance. The stars are no longer merely distant luminous points, but rather locations possessing quantifiable separations. These distances being articulated not in kilometers but in terms of years of travel. This conceptual transition, from assessing distances based on human-scale movement to calibrating them by the universe's intrinsic rhythm, utilizing the fastest signal known, profoundly reshapes our understanding of the celestial sphere. One then commences to grasp the imperative for astronomers to employ metrics transcending those utilized on Earth, as the cosmos extends far beyond any terrestrial vista the human intellect developed to comprehend. When light defines the contours of a landscape and one starts to conceptualize things this way, nearby stars cease to be simple points. Instead, they transform into destinations with distances etched, not onto charts, but directly into the fabric of time. If you start perceiving light not merely as brightness, but as a journeyer, a significant shift occurs in your cosmic comprehension. Light stops being an immediate communicator and instead transforms into a marathon participant, traversing vast celestial expanses. It conveys data much like rivers transport sediment, gradually, consistently, and wholly influenced by the topography it navigates. Given the immense scale of the universe, light's passage is never insignificant. Even its incredible velocity is diminished by the vast expanses it has to traverse. The initial phase of this fresh perspective involves light's second, 300,000 kilometers. In just 1 second, light covers a span nearly equivalent to the distance separating Earth and the Moon. Picture the Moon abruptly illuminating, an obviously impossible occurrence, yet entertain the idea briefly. The radiance visible from Earth would represent a communication transmitted nearly instantaneously, though not entirely so. Its arrival would require slightly more than a second, serving as a brief testament that even the swiftest entity recognized by physics is still bound by the principles of spatial dimensions. Extend that second, and a light minute emerges as a novel unit of measurement, 18 million kilometers. Our sun lies approximately 8 of those minutes distant. This signifies 8 minutes of uninterrupted movement for light to traverse the void separating a star and a planet, the solar rays warming your skin on a chilly morning. Departed the sun while you were still engaged in brushing your teeth, preparing your coffee, or rousing from slumber. Each individual ray brings a piece of the past. This temporal lag is delicate, almost lyrical. Throughout the majority of human existence, this went unobserved. The sun would ascend, and individuals would perceive its warmth without contemplating the duration of its journey to reach them. However, upon the revelation of light's finite velocity, the perception of immediate communication vanished. Even the closest star communicates with us not in real time, but by presenting only its recent past. The cosmos, as it happens, consistently lags a little. Venture further and the figures expand. A light hour spans more than 1 billion kilometers, denoting distances so immense that even our most daring expeditions grapple with the consequences. When the Cassini probe transmitted photographs of Saturn back to our planet, every single image journeyed for over an hour prior to its arrival. Cassini observed Saturn considerably earlier than we did. It documented swirling tempests, complex ring systems, and the silhouettes projected by remote moons. Yet, here on Earth, researchers consistently had to wait, as each instruction and every visual had to traverse that hour-long expanse of vacuum. It resembled conversing down an incredibly extended corridor, where every utterance required its own duration to reach the recipient. A light day extends that metaphorical passageway across almost 26 billion kilometers. At this magnitude, our most remote probe, Voyager 1, transforms into a sort of wandering temporal vessel, following almost 50 years of continuous travel. Voyager remains merely approximately 1 light day distant. Consider that, tens of thousands of kilometers hourly, year upon year, and decade after decade. Even after less than a single full day of light travel, space, even near our home, is incredibly immense, extending beyond a light day and into a light week. Our solar system starts to recede from view, resembling a far-off coast. Though the sun still emits light here, it no longer possesses the immense presence familiar to us on Earth. It transforms into merely one more luminous star in the heavens, a guiding light amidst innumerable others. The planets, prominent in astronomy texts such as Jupiter, Saturn, Uranus, and Neptune, diminish to minuscule, unobservable points. Their complete orbital paths condense into a compact, sparkling aggregation encircling a solitary point of illumination. From this vantage, the solar system appears not as an expansive realm, but rather as a small isle adrift within a cosmic ocean. If this journey is prolonged to a light month, approximately 778 billion kilometers, the Sun then becomes an unremarkable star among thousands. No distinguishing features mark it. Nothing indicates its function as Earth's source of life. Were you to be suspended in space at this range and unaware which luminous point represented the Sun, you would be unable to locate it visually. Our familiar home star, which dominates our firmament, would simply be another speck, among countless others obscured by the Milky Way's sparkle. The magnitude is so vast that the very concept of home starts to lose clarity. Following this, the light year itself emerges. This immense distance necessitates ascending through all the preceding steps of this ever-growing progression. Gather 365 of those light days, 52 of those light weeks, and 12 of those light months, then arrange them consecutively. The total span achieved is 9.46 trillion kilometers. It represents more than a mere figure. It's an expansive terrain, quiet and largely vacant. Yet it also serves as a precisely engineered unit, a measuring tool shaped by light's unceasing movement. At this magnitude, the closest stars at last become visible. Proxima Centauri, our Sun's nearest stellar companion, is situated just over 4 of these light years distant, not millions of kilometers, nor billions. This equates to 4 years of uninterrupted journey for light, the universe's fastest traveler, proceeding at the highest velocity permitted by the cosmos. Nevertheless, from an astronomical perspective, Proxima Centauri is virtually close by. It belongs to our immediate cosmic vicinity, much like a neighboring settlement is part of your geographical area. However, unlike such a town, one cannot reach it by driving, flying, or even conceive of arriving there using any human-made craft. This illustrates how the concept of a light year transcends a mere measurement. It serves as an indicator of how spatial separation influences temporal perception. When viewing Proxima Centauri via a telescope, you are observing it as it appeared 4.2 years prior. Should any significant event occur there, a stellar flare, a reduction in brightness, or even a catastrophic incident, you would remain unaware for years. The star might disappear right now. Yet for over 4 years, its visual representation would persist in our firmament, akin to a specter oblivious to its own demise. The greater the star's distance, the deeper into the past we are observing. Stars located 10 light-years away reveal themselves as they were a decade ago, while those 100 light-years distant display the world from the era when steam engines first emerged. Light from stars 1,000 light-years distant started its voyage when medieval stargazers mapped the skies without telescopes. This is not a figure of speech. This is factual. Space functions as a time machine since light traverses it at a limited velocity, and once this is understood, the nocturnal firmament transforms into a sort of celestial exhibition. Every luminous point represents an exhibit, captured at a specific instant in its individual past. The further one gazes, the more ancient the cosmos seems. Light years evolve beyond mere measurements of separation. Instead, they signify ages. Each star embodies a narrative whose conclusion remains unseen and whose current state is unknowable. You exist perpetually, out of alignment with the surrounding universe. This intricate connection between spatial separation and temporal progression stands as one of the most magnificent outcomes of light's velocity. The cosmos is not a concurrent tableau, such as a painting or a chart. Rather, it's a multi-layered fabric where occurrences manifest at varying times, contingent on their original distance. Space possesses immense depth, and each deeper penetration transports you further back in time. Consequently, a light year transcends a simple measurement. It serves as the link connecting the present and the past. It represents the span of the cosmos's recollection, the quantification of the inherent lag in every observation of the stars. Time equates to distance, distance equates to time. Within the cosmos, these two concepts are perpetually intertwined. Humankind frequently envisions the universe as an expansive frontier, an immense, untamed expanse awaiting traversal. Provided with appropriate instruments, sufficient bravery, and a fortunate technological breakthrough, we envision grand vessels navigating between stellar bodies, with generations born and passing away amidst the constellations. Voyagers would journey from one star system to another with the same ease that ancient mariners once traversed from isle to isle. This is an alluring prospect, brimming with optimism and aspiration. However, upon scrutinizing the interstellar distances through the perspective of light years, that aspiration transforms into something considerably more delicate, something molded not by hopeful outlooks. Instead, it's shaped by the rigorous spatial arrangement of the universe. The closest stellar arrangement, the Alpha Centauri triple system, is situated 4.24 light-years distant. In a textbook diagram, that separation seems achievable, almost trivial. Yet, in actual physical space, 4.24 light-years constitutes an abyss so vast that even the swiftest spacecraft ever constructed by humans, such as Voyager, New Horizons, and the Parker Solar Probe, would require tens of millennia to traverse it. These exploratory craft move at velocities that astound their creators. Despite this, they merely creep when compared to the immense pace of light. Picture yourself standing next to a motorway where vehicles zoom by at incredible velocities. Now envision that the quickest vehicle ever constructed for that particular road travels at less than 1% of the posted speed limit. That precisely describes the predicament humanity faces. The celestial thoroughfare has a designated maximum velocity, the speed of light, and everything we are capable of constructing presently advances at a rate that would scarcely register on the universe's speed indicator. But let us assume we persist in our aspirations. Suppose we develop propulsion mechanisms vastly superior to the chemical rockets we currently depend on, systems that could propel a space vehicle to a significant percentage of light speed. Humanity's most daring theoretical designs contemplate achieving 10% of that maximum velocity. Even at 1/10 the speed of light, traveling to Proxima Centauri would still require more than 4 decades, representing a lifelong undertaking. This journey entails the possibility that those who leave may never come back, and those who reach their destination could be aged, more subdued versions of the individuals who departed their original home, and this is only if all aspects proceed flawlessly. The vacuum of space is not truly vacant. It holds particles of dust, tinier than individual sand grains, each traveling at a leisurely pace concerning the sun, yet effectively becoming projectiles. Should you be hurtling through the emptiness at speeds reaching tens of thousands of kilometers every second, an impact with even a minuscule particle moving at a considerable fraction of light's velocity has the potential to create a crater in your vessel's exterior or completely dismantle a spaceship. Moving at speeds sufficient to reach the stars transforms the space between them into a hazardous zone. Protective barriers would be necessary, but such defenses increase weight and mass perpetually hinders acceleration. Furthermore, the challenge of power arises when attempting to propel a spacecraft to 1/10 the speed of light. Necessitates an energy quantity that pushes the boundaries of current human comprehension. A craft sufficiently sized to transport people would need power supplies that are both more potent and more consistent than any technology we have ever constructed, such as nuclear fusion, antimatter, or other unusual notions derived from theoretical formulas. Instead of practical application, these concepts remain on the fringes of scientific understanding, partly feasible and partly speculative. But even if we overcome these obstacles, even if we constructed a vessel able to accelerate, navigate, and endure journeys spanning light years, a different impediment emerges: time itself. Einstein demonstrated that time exhibits peculiar characteristics. When traveling at extreme velocities, an individual approaching the speed of light perceives time passing at a reduced rate compared to the planet they departed. A journey to a star located many light years distant, involving both departure and return, could seem like only a few years for those on the ship, yet on Earth, many decades or even centuries might elapse. A crew coming back would disembark from their craft, not into the familiar world they departed, but rather into its far-off future, finding friends vanished, families transformed, and nations altered. They would effectively become voyagers through time, not through their own volition, but due to the fundamental essence of existence. For individuals envisioning colonization among the stars, the ramifications are more profound. Interaction between planets divided by light years progresses at an extremely slow pace. A communication sent from Earth to a settlement situated 4 light-years distant requires 4 years to reach its destination, and a response would take an additional 4 years. Consequently, one complete conversation could extend over almost 10 years. Administration, cooperative efforts, and common cultural practices all start to break down due to the burden of temporal lag. Settlements gradually move towards self-governance, not from an act of defiance, but from sheer practical need. Each planetary body transforms into an isolated entity within a vast celestial chain. They are too widely separated for their historical timelines to stay aligned. Consider a settlement located 10 light-years from Earth. A message dispatched to them today would not arrive until the middle of the 2030s, and their response would return around the mid-2040s. By that point, the circumstances that initiated the initial message could be outdated. Information reaches them belatedly. Counsel arrives even later, and urgent situations resolve themselves long before assistance can be provided. Each dialogue becomes a sequence of reverberations extending over many decades. This temporal separation constitutes a barrier as tangible as any measured in kilometers. Space doesn't merely divide worlds physically, it also isolates them across different timeframes. Now let's expand our view further. Ponder the potential for intelligent existence elsewhere in the galaxy. With its hundreds of billions of stars, it seems improbable that Earth is truly solitary. Yet even if the galaxy is teeming with advanced societies, the light-year spans separating them could be too immense for either dialogue or even discovery. Consider a planet located 1,000 light-years distant. Might harbor a thriving technological civilization, but the light arriving here from it originated centuries in the past. They could be transmitting signals right now. Nevertheless, those transmissions won't arrive until a distant future, and the signals we emit today will journey through the galaxy long after. Our descendants have long forgotten their original senders. Within a universe governed by the finite speed of light, communication effectively transforms into archaeology. Each message serves as a relic. Every received signal is a spectral trace of a civilization as it existed previously, not as it currently is. Worlds are incapable of direct dialogue. They can only exchange historical records. Yet grasping this truth does not lessen the star's appeal. Instead, it heightens it, for the very barriers the universe establishes are not signals for retreat. They are instead invitations to conceptualize exploration in a new way. Traversing to another star might require decades or even centuries. However, even that duration is merely a fleeting moment when contrasted with the galaxy's age. A generation vessel, a craft where entire communities are born and pass away. While journeying between suns might appear impractical on human timescales, but on cosmic timescales, it is simply another subtle ripple of movement. Should humanity endure, it will not be due to the universe's smallness, but rather because our aspirations expanded enough to align with its vast scale. The reality is that interstellar journeys compel us to reevaluate what is considered attainable. It prompts us to question whether exploration must necessarily occur within a single lifespan, or if the expedition itself can transform into a collective legacy handed down from one generation to the next. It queries whether distance genuinely isolates us, or if we are capable of forging meaning across such immense temporal spans that they once appeared impossible. The light year is not merely a metric of separation, it is a metric of potential. A possibility that calls for patience, imagination, and an acceptance that the cosmos was not constructed for convenience, but for awe. For as long as humans have directed their gaze upward, we have pondered whether someone might be observing us in return. The night sky appears too immense, too ancient, and too densely packed with stars for us to be solitary. Yet throughout all the centuries of listening, via radio telescopes, through mathematical patterns, and with a quiet hope, we have detected nothing. No transmissions, no communications. No cosmic salutations drifting through the darkness. Only a silence as profound and expansive as the distances separating every star. Understanding the reason for that persistent quietude commences with the very same concept that redefines our perception of distance: the light year. This is because the light year is not merely an indicator of an object's distance. It also quantifies the duration required for information to reach us. For instance, observing a star located 50 light-years distant, we are perceiving it in a state that predates the birth of numerous individuals among us. When we attempt to detect transmissions from such a star, we are essentially tuning into signals dispatched 50 years prior. Every element within the cosmos transforms into a form of temporal container, with each separation introducing a lag. Envision a proximate star, among the nearest in our cosmic vicinity, situated at a remove of 40 or 50 light-years. Should a civilization residing there have developed radio technology during the 1970s and commenced transmitting their versions of music, news, or casual discourse into the void, those emissions would only now be making contact with the periphery of our solar system. This scenario assumes they deliberately aimed their transmissions towards us, utilizing a frequency we employ and with sufficient power, robust enough to withstand many decades of diffusion and attenuation as they propagate outwards through an ever-enlarging void. Our own emitted signals exhibit identical behavior. Our television programs, radar emissions, and scientific data transmissions have been escaping into space for approximately 100 years. All these signals are propagating outwards at the speed of light, thereby creating a continuously expanding sphere of subtle electromagnetic interference. This sphere currently spans approximately 100 light-years. For any civilization situated beyond that perimeter, we appear to be silent. To a civilization located within its confines, we might register as nothing more than a faint murmur, obscured by the pervasive cosmic background noise. Even if an extraterrestrial entity were actively attempting to locate us, they would require exceptional fortune. They would have to tune in at the exact opportune moment and orient their detection equipment at the precise correct angle, and furthermore, operate on the exact appropriate frequency. Their detectors would need to possess sufficient sensitivity to distinguish our weak emissions from the cacophony produced by stars, galaxies, and the universe's inherent subtle resonance. Even upon achieving success, their discovery would merely indicate that an entity, at some point and location, had broadcasted a signal. They would remain unaware of our identity, our characteristics, or even our continued existence. Moreover, if they were to send a response, their communication would require many decades to arrive here. Should they be situated 50 light-years distant and issue an immediate response, that reply would reach us sometime in the 2070s. If their location were 1,000 light-years away, their answering message would lie a millennium in the future, extending well beyond the scope of our current plans, our established organizations, or potentially even the lifespan of our species. Interacting across such vast distances resembles the act of corresponding through epistles across multiple centuries. Each transmitted message constitutes an artifact, and every response is akin to a specter from bygone times. Temporal expanse transforms communication into a form of archaeological endeavor, an unearthing of concepts conveyed by individuals who have long since passed. Now, envision a civilization situated at an even greater remove, thousands of light-years away. Our galaxy, the Milky Way, is immense, and the typical separation between intelligent societies, assuming their existence, could readily extend to such magnitudes. At that juncture, even if they maintained continuous broadcasts for millennia, the inherent time lag would obliterate any prospect of genuine dialogue. One might dispatch a message and never survive long enough to ascertain its reception. Your distant descendants might also remain perpetually unaware. Entire societies could emerge and vanish before a solitary communication exchange could be finalized. It's conceivable that civilizations could disappear before their communications ever reach us, offering a potential explanation for the deep mystery known as the Fermi paradox. The cosmos seems sufficiently ancient, expansive, and abundant with planets for life to be prevalent. Therefore, why have we not received any contact? Perhaps our separation is too great, not merely spatially, but also temporally. Perhaps civilizations emerge and vanish swiftly, akin to sparks from a fire that glow intensely for a short period. Subsequently, they dim long before their transmissions could ever reach another distant light. It's possible the galaxy teems with life. Yet each world's period of broadcasting is fleeting. Their communicative phases might coincide purely by happenstance. The light year thus serves as a metric not solely for spatial separation, but also for lost chances, spanning hundreds, thousands, or even entire eras. An alternative scenario exists, again rooted in immense scale. Communication itself could prove futile across cosmic expanses. Consider a civilization situated 20,000 light-years distant on the opposite edge of the galaxy. Their transmissions would require 2 millennia to arrive here, a time frame during which the human race itself could undergo significant evolution. During that span, we might transform or cease to exist. Our linguistic forms would become unrecognizable, and our technological advancements could either decay or progress to an incompatible state. Upon the arrival of their response, neither party would remain unchanged. Exchanging information across such immense distances doesn't truly constitute a dialogue. It resembles a sealed message in a container, traversing an oceanic expanse that covers geological epochs. Nevertheless, even if direct communication proves unfeasible, life itself might not be uncommon. Life could potentially be ubiquitous, present throughout. However, the vastness separating these pockets of existence is so immense that each remains secluded within its own profound cosmic isolation. The light year transforms into a barrier, not one of material substance, but rather of time and data, a partition constructed not from masonry, but from inherent latency. From our vantage point on Earth, beneath a firmament ablaze with stars, this sense of solitude can be deeply unsettling. Every luminous speck could potentially host vast oceans, land masses, woodlands, or entities that ponder existence just as we do. They could construct observatories, dispatch exploratory craft, chart their celestial spheres. They might recount narratives of their position within the cosmos. Yet the illumination from each star requires years. It takes centuries or even millennia to arrive at our location. Consequently, every civilization, should it exist, functions as a solitary beacon operator projecting its light into the vast obscurity. They are perpetually uncertain if any other entity is sufficiently close to perceive their presence. However, being isolated does not equate to being inconsequential. Indeed, this very isolation might be the fundamental reason why consciousness holds such profound importance. If we are genuinely divided by immense cosmic spans, if no utterance can ever bridge the temporal chasms, then each sentient species possesses a singular perspective on the universe. We do not form a unified choir. Instead, we are distinct solo performers dispersed throughout the galaxy, each vocalizing into the identical void from disparate vantage points. And such profound aloneness can possess its own inherent beauty. For if no other entity can partake in our precise perspective, our specific celestial view, or our exact lived encounter, then our perceptions and comprehension become exclusively our own. Our narratives, our findings, and our understandings of the universe's past possess an inherent importance that does not lessen simply because no other beings are able to perceive them. The quiet expanse separating stars doesn't confirm our isolation. Rather, it demonstrates the universe's immense scale, too profound for mere discussion, too ancient for simple interaction, and too deep for casual discourse. Within such immense scope, our role isn't to lament the stillness, but instead to cherish the unlikely wonder of our very existence and our capacity to gaze into the cosmos. We measure these distances, yet we perceive something deeper than mere figures when we stand under the nocturnal heavens and gaze into the darkness separating the stars. You're not observing a void. Rather, you're peering into an abyss that light itself finds challenging to traverse, an abyss that divides more than just locations. It separates histories, a chasm ensuring each star retains its mysteries until light, with patience and steadfastness, conveys them to us many centuries following their genesis. Nevertheless, notwithstanding this vast division, something significant transpires whenever we lift our gaze. We span a minuscule segment of that immense chasm. This is achieved not through spacecraft or exploratory devices, but through comprehension. We perceive stars as they appeared long before human societies emerged, and within that primeval radiance, we discover a link, not to other life forms, but to the universe itself. We come to realize that we constitute a component of something immeasurably immense, not adrift within it. but rather enlightened by it. The cosmic stillness is not vacant. Instead, it is replete with duration and expanse. It's brimming with narratives still journeying in our direction. And amidst the profound quietude separating celestial bodies, we discern our position. Diminutive, certainly, yet sentient. Fleeting indeed, yet cognizant. The light year challenges the boundaries of our grasp, but concurrently delineates the extent of our awe. And occasionally, awe proves sufficient. A moment arrives when reflecting on the light year, where the cosmos starts to appear almost too immense to be contained within human conceptualization. The galaxies we chart, the stars whose separations we calculate, the dim illumination reaching us from the nascent universe, these are phenomena we can quantify with remarkable exactitude, yet we are unable to genuinely visualize them. Our scientific apparatuses become more refined annually, whereas our innate understanding stays anchored to terrestrial vistas and boundaries. This generates a dichotomy between our acquired knowledge and our sensory perception. Such a dichotomy takes on an almost lyrical quality when extended over eons and countless kilometers. Nonetheless, in a peculiar manner, the further we investigate, the more the cosmos appears recognizable, not due to any reduction in its size, but rather because we start to discern recurring structures within its vastness. The stars are remote, yet they are also kindred. The galaxies appear inaccessible, but they are composed of the identical constituents as our own. Even the most isolated regions of space, well past any prospect of voyaging, adhere to principles we have discovered right here on our planet. Gravitation, illumination, movement, temporality, these phenomena operate identically wherever we observe. This uniformity, extending across immeasurable expanses, unveils something nuanced concerning the fundamental framework of existence. It posits that the cosmos is not a disordered expansion of disconnected elements, but rather an integrated entirety. The principles of physics resemble a common tongue spoken by everything, from the tiniest particles to the grandest galactic clusters. And once you start perceiving the cosmos in this manner, its immense scale transforms from merely daunting to surprisingly personal. You grasp that the galaxies, floating billions of light years, distant, are not alien territories. They consist of the identical cosmic dust that forms your own being, and their stars undergo birth and demise governed by the same principles. Their chemical composition mirrors ours, and their lifespan aligns with the same universal chronology. Yet even as this sense of kinship deepens, the expanses keep extending. Light years amass into scores of thousands, then millions, then billions, and with every progression further out, the cosmos doesn't merely expand in size, but also, in a way, more ancient. Separation is merely time concealed. Observing distant objects means peering profoundly into history. A galaxy situated a billion light years away reveals a universe a billion years less old. A galaxy located 10 billion light years from us unveils a period when stars were newly formed and planets were barely present. Thus, the universe transforms into a colossal repository of information. Each direction you gaze holds a distinct segment of an ongoing narrative. This capacity to observe history firsthand represents one of the most remarkable consequences of the light year. While on Earth, history endures through fossils and ancient structures. In the heavens, it persists within photons that departed their origins millions or even billions of years ago, journeying continuously since then, pristine and undisturbed, conveying unspoken information throughout the ever-expanding cosmos. When the James Webb Space Telescope views galaxies over 13 billion light-years distant, it isn't merely examining antiquated pictures. Instead, it is capturing primeval light, radiation that began its journey far preceding Earth's existence, well before the sun's ignition and long before our galaxy had even finished. A mere segment of its revolution around the galactic core. Consider the profound implication. The most ancient light we are able to perceive commenced its voyage as matter was only starting to coalesce into the formations destined to become stars and planets. That particular light traversed through eras when galaxies were coming together, clashed, developed, and reached maturity. It journeyed through expanding cosmic space, which elongated its wavelengths, thereby converting it from intense radiation into subtle, reddish murmurs. And following billions of years of continuous passage, a portion of those photons encountered a telescope circling a modest planet orbiting an ordinary star. They entered its reflective surfaces, and in that singular instant, the cosmos unveiled to us a glimpse from its nascent stages. This exemplifies the profound capability of light years. They transform spatial separation into historical record. They illustrate for us not merely the current location of objects, but also their past existence. To comprehend light years is to grasp that the nocturnal sky does not represent a solitary point in time, but rather a vast tapestry composed of various epochs. Each star functions as a temporal container, and every galaxy serves as a communication, postponed by the spatial configuration and the finite speed of light. Consequently, every observation constitutes an act of retrospection, occasionally reaching incredibly distant pasts. That the familiar arrangements of the cosmos transform into something nearly unrecognizable. Yet the further we observe, the more an extraordinary truth is revealed. Not every distance can be traversed, not even by light. There are cosmic regions from which no information will ever reach us, not because they are conventionally too far away, but because the universe's expansion is propelling them away at velocities greater than light can overcome. They lie beyond a cosmic boundary, an unseen demarcation marking the limit of what is observable. Beyond that horizon exist galaxies whose illumination can never arrive here, whose stars will never be visible through any of our telescopes, and whose presence can only be inferred from cosmological mathematics. This is not a technological constraint. It's not about superior telescopes or undiscovered new physics. It's an inherent characteristic of the universe itself. A light year is more than just a unit of distance. It quantifies the maximum extent of the universe we can ever hope to perceive. It defines the boundary of our cosmic vision, and that limit is not fixed. As space expands, an increasing number of galaxies slip beyond it. One day, billions of years in the future, our local cosmic area will be the sole region of the universe we can observe. Everything else will recede beyond reach, not because it dims, but because the cosmos outgrows our capacity to witness it. And yet, somehow, this realization does not diminish the splendor of what remains. In fact, it amplifies it. It signifies that what we perceive today is uniquely precious. These star systems, these groupings, these faint traces of ancient light, they collectively form a transient glimpse of a universe that is undergoing transformation, not only temporally, but also in its accessibility. We exist at a moment when the cosmos is still open to us, still offering views across billions of light years before the great expansion carries its mysteries away. We are observing the concluding acts of a spectacle that future civilizations will never witness. This awareness brings with it a subtle responsibility. Comprehending the universe, truly grasping it, is not merely an act of scientific inquisitiveness. It serves as a method for safeguarding the narratives the cosmos imparts to us. As long as we persist in outward observation, in measurement, interpretation, and imagination, we evolve into the chroniclers of a universe that is gradually fading into quietude. Light years quantify not only physical separation, but also the profundity of our bond with the cosmos, representing the extent over which we can compile its past. And that connection extends internally as well. Every atom within your physical form, the carbon in your cells, the oxygen in your bloodstream, the calcium in your skeletal structure originated in stars that existed and perished many eons before our planet came into being. Certain atoms were created deep within primeval suns, while others formed during the violent demise of colossal stars dispersed throughout the galaxy. A small number even stem from cosmic occurrences so intense they are uncommon throughout the universe. Neutron star mergers, where elements denser than iron are forged. In one instantaneous, brilliant flash, the material that ultimately constituted you journeyed across vast light-year distances before coalescing into the nebula, which gave rise to our solar system. In this way, you too are a voyager. Your constituent atoms hold the imprint of light years, having once journeyed through the cosmos long before any life emerged, came into being. These particles were sculpted by energies predating any planet, forming a segment of a universal narrative that commenced eons ago, and currently, they constitute a sentient entity, able to gaze skyward and comprehend its own genesis. This perhaps stands as the most extraordinary outcome of the light year concept. Its significance extends beyond merely quantifying the separation of stars. It gauges the progression from inert substance to sentience, from particles dispersed by stellar explosions to a consciousness, able to ponder its own universal ancestry. The light year illustrates the immense chasm separating the past locations of your atoms from their present configuration into an entity that can perceive through the dimensions of space and time. The cosmos is immeasurably immense, stretching beyond grasp, replete with spans no vessel could ever traverse, nor any signal will connect. Yet within that immense expanse, an exceptional event transpired. A modest world circling an unremarkable sun gave rise to life, which became sufficiently inquisitive to quantify the very cosmos that formed it, thereby imbuing an otherwise indifferent universe with significance, unconcerned. At the outset of our exploration, the light year appeared to be a mere precise scientific phrase, something one might encounter in a factual program and accept without scrutiny. However, having now traversed the expansive realms of distance and temporal duration it encompasses, it transforms into something considerably more significant. The light year signifies more than mere spatial separation. It serves as an indication that the cosmos extends far beyond what our innate understanding can grasp, yet remains, in some manner, comprehensible to human intellect. It presents a challenge by transcending the scope of our daily existence, but it compensates us by unveiling the concealed framework of the universe. Each star you observe represents a communication from bygone eras. Every galaxy embodies a narrative developing across millions or billions of years. Even the dimmest speck of illumination in the nocturnal heavens could have commenced its voyage long before humanity acquired the abilities to vocalize, cultivate, transcribe, or envision anything beyond their immediate view. Grasping the concept of light years, it is not merely about committing figures to memory. It involves acknowledging the connection between that which is palpable and that which remains forever beyond our grasp, between the ground we stand upon and the inconceivable expanses encircling it. It represents a change in viewpoint, a subtle realization that redefines your perception of all things, from the celestial dome to your personal existence. Ultimately, the sheer magnitude of the cosmos does not lessen our significance. Rather, it enriches us, serving as a reminder that our composition is of material, formed within primordial stars, molded by universal occurrences dating back billions of years. The cosmos is immense, yet we are an intrinsic part of it. We serve as its witnesses, its narrators, its fleeting yet luminous observers. Therefore, the next occasion you venture outdoors on a cloudless evening and direct your gaze upwards, permit yourself to sense the immensity of those separations. Allow yourself to envision the photons journeying for years or even centuries to arrive at your location, and recall that for a brief interval, you are directly linked to the chronicle of the universe. If you appreciated this journey, a like and a subscribe genuinely supports the channel's growth. We appreciate your viewership, and may your perception of the stars be forever altered.